Welcome to Integrated Math 3. On this episode, Stevenson will demonstrate Now that we have our unit circle with coordinates, I'm going to show you how we can use those coordinates to create one of our parent trigonometric functions. We're going to look first at the sine function. So in order to do this, you need to have your unit circle handy. So we have our unit circle done. So what we're going to do is we're going to pull the sine values from here. So that means you're going to pull only the y coordinates at particular angles. Let's get started. Now when you want to graph the parent sine or cosine function, you don't have to pick every single angle. What you can do is pick the 90 degrees. And remember, sine is a periodic function because it's created going around that circle, right? So all we have to do is one period and then we can repeat the pattern. So look at your unit circle. What is the sine of the angle at 0 pi? So again, you're looking at the y coordinate. The answer is 0. At pi over 2, the sine of that angle is positive 1. At pi, the sine is 0. At 3 pi over 2, the sine is negative 1. And at 2 pi, it's back at 0. So we're going to use these coordinates now, and we're going to graph. Now I want you to notice something. When you do your graph here, you're going to have negative 1 to 1 here. But along the x-axis, I want you to scale it according to these angles here. So let's begin. Now I want to do the left side, so all I have to do is kind of go in reverse. So if I'm at negative pi over 2, if you follow the pattern here, we're going to be down here at negative 1, then we'll come back up at negative pi, then we'll go back at negative 3 pi over 2, come back at negative 2 pi. So some of you may be wondering, well Stevenson, how could I find these negative angles using the unit circle? Well, all you have to do is change your direction. So in the unit circle, when the angle's positive, we start here and we go in a counterclockwise direction. But if your angle's negative, you still start in the same spot, but instead you go clockwise. Just like that. That's how you can get those other points. Or you can just follow the pattern. Now let's do our sketch. This is periodic, so make sure it's curved. Of the characteristics, some of them do repeat forever. Okay, just so we're not going to do all of the ones, like you might be wondering why are there no x-intercepts here. Remember, this thing is periodic. It continues in both directions forever, so it has an infinite amount of x-intercepts. So we're going to focus on the main characteristics here. The domain of sine is all real numbers. The range, if you notice, is negative 1 to 1. The midline is the x-axis there. So now the amplitude, you can see, is going to be 1. Now let's talk about the period. This is one of those concepts that I know we tend to struggle with. So let's start at the origin here and just kind of follow it. Okay, if I stop there, I've only repeated that part, so I'm going to keep going. And now I would stop here. Now if I stop here, I can see I've gone back to 0, but I've covered both the values above and below the midline. If I were to keep going, I would then begin to repeat the values above the midline. I've already covered those, so I can stop. So from 0 to 2 pi tells me 2 pi is the period. What is the maximum of this function? It is 1. What is the minimum? It is negative 1. And what is the y-intercept? Sine goes through the origin.